What are repeating decimal numbers? When we change some fractions into decimal numbers, we find that the decimal numbers never stop. Let's look at the fraction 2/3. To convert this fraction to a decimal number, we use long division. We write the problem 2 divided by 3. Since 3 will not divide into 2, we put a decimal point and a 0 after the 2. 3 divides into 20 6 times. 6 times 3 is 18. When we subtract 18 from 20, the difference is 2. We add another 0 in the dividend and bring that 0 down. Again, we see that 3 divides into 20 6 times. The difference is 2 again. We add another 0 and bring it down. We are dividing 20 by 3 again. 3 divides into 20 6 times, and 6 times 3 is 18. Again, the difference is 2. We add one more 0 in the dividend and bring the 0 down. 3 divides into 20 6 times. 6 times 3 is 18. Do you see the pattern in this problem? In each step, we see 20 and 18. Subtracting 18 from 20 gives us 2, and the pattern continues forever. The fraction 2/3 is equivalent to a repeating decimal number. The 6 repeats forever. What are some other repeating decimal number patterns? Let's look at some repeating decimal number patterns. We already know that 2/3 equals this repeating decimal number. The 6 repeats forever. The improper fraction 20/11 is equal to this repeating decimal number. The 81 repeats forever. Let's look at the improper fraction 34/7. This fraction is equal to a more complex repeating decimal number. Can you see the pattern? In this case, the digits 8, 5, 7, 1, 4, 2 repeat forever. There is an easier way to show the repeating pattern when we write repeating decimal numbers. We put a line over the part that repeats. Here is our first decimal number with the line over 1/6. In the second decimal number, we put the line over the digits 8 and 1. In the last decimal number, we put the line over all 6 digits that repeat. Remember that the line tells us that the digits repeat. Let's look at 20 fractions and their decimal number conversions. Some of the decimal numbers will be repeating decimal numbers, and some will not. Let's look at the fractions that are non-repeating decimal numbers. 8 of the fractions convert to non-repeating decimal numbers. 12 of the fractions convert to repeating decimal numbers. You will find that repeating decimal numbers are very common.